So let's say, like I was saying, we have done differentiation of exponential function. We have done that of implicit function. We saw the techniques in differentiation like that. But let's just show you one thing before we move into real partial derivative. We have applied, Abi. We have done application of gradient. We have done minimum and maximum.
Minimum and maximum.
Yes, we'll still, I hope you understood that, Abi.
Yes.
I will just do one more thing on that one, just one question. We'll just see whether you still remember. Because if, for instance, the total function is given, we'll be able to apply that minimal and maximal in some questions. So let's see how that will go before we move on to partial derivative proper. Let's take one small question here. Okay, right. Question 1 for today, still on that minimal and maximum. One more question, then forget that one. Obtain, question 1, obtain, obtain the value, obtain a maximum value, obtain a maximum value, obtain a maximum value of the function. Obtain a maximum value of the function. Obtain a maximum value of the function. Let's do it like this. Obtain maximum and minimum values of the function so that we can do 2. Y equal to x raised to power 3 minus 12x plus 11. Are you there?
Yes.
Good. So the number way we do it, which I don't know whether you remember.
Are we are going to differentiate first?
Okay, can you differentiate? Okay, let me differentiate.
3x squared.
That means if you have to differentiate x raised to power 3
minus 18.
Okay, I'm coming. 12x
minus
plus
12.
11. Okay, so if you have to differentiate, divide the s, you say is what?
3x squared minus 12.
Square minus what?
12.
Good. Good. Now, after this level, what do we do? Tell me, what's the next thing?
After this level, we'll...
Our turning points?
Yeah, turning points. Divide the x equals to 0.
Good. That means you have to equate 3x squared, Abi?
Yes.
3x squared minus 12. Equate it to 0. You will get 2 values, Abi?
Yes.
Now let's see what you can do.
So I will get x squared. Is it x squared? X squared minus 4.
Minus 4
is equal to 0.
What's your final answer? There should be 2 values for x, Abi?
Yes.
Because it's quadratic, there must be 2 values for x. So what do you have?
We have x minus x minus x minus 4. The x minus 4 and plus 1.
Okay.
X minus x plus 1. Is that correct?
So what's the answer? X is what? X is what?
X minus 4 and x minus 1
minus 12 equal to 0. When you solve, you should have this, Abi. Solve it again. You have 12 over 3, Abi.
Yes.
Solve it again. You have s equal to 4, Abi.
Yeah.
Now our x is equal to the square root of 4, abi?
Yes.
X is plus or minus 2. Because the square root of any number is positive or what? Negative. So our two values are this. Is it clear?
Yes, but is it because this equation is 3x minus 12? That's why we just like this.
No. You know it's
Because that other one that we did, we got.
You know it's good.
Okay.
Where we factorize, Abby, and I'll see you can do this. S squared minus 4 equal to 0. Abby?
Yes.
From here. So you can now say x minus 2 into x plus 2 equal to 0. This is what we call difference of two squares, Abby?
Yes.
Another difference of two squares, we have a squared minus b squared equal to a minus b into a plus b. That's the formula for difference of what? Two squares. Is that okay? So what you're seeing on the board here is s squared minus 4. And that form means 2 squared. So s squared minus 2 squared will come out to be s minus 2 into s plus 2. And that gives us x is equal to 2 or minus 2. But, so you either go this way, this way, or this way. So whichever one. But you must get two values because it has power 2. That makes it quadratic. And you must have two values. Is it clear?
So yes, so the minima is the minus 2.
No,
and the maxima is plus 2.
No, you have not gotten it. No. We have just gotten the value of x. This x will go at the corresponding turning point of y. We need to substitute. You will substitute x in the original function to get y.
Okay. Is that answer you get now that will determine the minima or the maxima?
Is that answer for y? The two values of y. Now that's what we determine. Now, why you differentiate, just like the question you sent to me now. In that question, there is total cost function, Abby?
Yes.
Abby?
Yes.
In that total cost function, if I differentiate, what I would just write is TC equal to that thing you gave as total cost. Then when I differentiate it, I will get marginal cost. Are you with me?
Yes.
I will show you more, but we'll still look at that question later and see whether I will solve it if the thing is the way I like it. And I'm seeing that Q I'm seeing, but just believing it's a variable. I expected what is it called? Demand function to be with a price, but no worry, the quantity could be a variable, so we can use it like that. It doesn't matter. But what is important here is that because demand function is also the same thing as quantity, I mean?
Yes.
Quantity demanded, so which is Q, and we can put a price. Our price can be Q as well. It doesn't actually matter, so that the variables will work. But to look at it for you. But you must understand what you are doing. You must understand some theory about profit. Maybe you do accounts, Nabi?
Yes, I do accounts.
You know that profit is represented with pi. Hello? Are you aware?
Sorry, I didn't get that.
This symbol is pi, Abi?
Yes, pi.
And this symbol is represented as profit in economics, Abi?
Yes.
So one will now use this symbol as profit. And profit is same thing as total revenue minus total cost. Am I correct?
Yes.
So these are the things that you come up with. When you come up with that, for instance, we have gotten total cost. We're going to find total revenue. And how do we find total revenue? Total revenue should be quantity times price, are they?
Yes.
And our price can be represented with any alphabet. I can say, let my price be Q. So that we're going to use the Q so that Q will be all right, because in that question, everything is all Q, are they?
Yes.
So when we get total revenue minus total cost, it's going to give us the total profit function. You know, that question mentioned total profit function.
Yes, it did.
So by the time I subtract the total revenue function, which the question also mentioned total revenue function. So by the time I use the demand, the quantity times the price, I'll get a total revenue function. And when I get total revenue function minus total cost, I'll get the total profit function. I begin to understand it is small.
Okay.
That I must have that knowledge of economics to be able to apply mathematics to that. And what you are seeing in that question is what we call application of differentiation, which we're already doing some part of it. We have done a gradient. We're now a minimum and maximum. And the question mentioned a maximum price, or quantity or something like that. So one can also solve in that manner. But we'll come back to that and deal with it. By the time I must have finished what I want to learn about differentiation. Is it clear?
Yes.
Is this one clear? So have you find substitute x equal to 2? What is your y?
Okay.
Yes, in that original
X plus 2.
When x is equal to 2, what do you have? When x is minus 2, what do you have?
2 raised to power.
That means we're expected to say when x is 2, y is equal to 3x squared, 3x cubed.
8 minus 24 plus 11.
3x cubed minus 11x minus 12x plus 11, have you? So whenever I see
minus 5.
Is that what you got?
Yeah, for x is equals to
2. So y is equal to this is 8. That's 24.
yes, it's minus 24 plus 11.
Plus 11. Are you sure that's correct?
Wait, though, that answer is not correct. 24 plus 11 minus 8, 27.
That means we're having 11 here, pardon. Okay. When x is 2, when
get
x
7
is 2 whole number, the question is
no, wait, though.
I want to know.
11 plus 8, 19 minus 24. Yeah, it's minus 5, no? It's minus 5.
Is it 5?
Yeah, minus 5.
The question. Okay. Oh, the question, I'm the one that wrote what is not said. The question was when x is what 2, is y equal to x raised to power 3, Abby?
When x is 2, y is equal to x raised to
power
3. Yes,
it's
yes.
Not 3x. I'm the one that wrote 3x. So that's why the thing, because I was wondering why would it be different than. So here is 12 into 2 plus what? 11. Here is 8 minus 24 plus 11. So is that the one you say got minus 5?
Yes.
So that one should be minus 16, then minus 5. And this one is negative. That is maximum, Abby.
Yes, that's maximum.
Minimum. No,
Yeah,
this
minimum.
is
Minimum.
So this is minimum or minimum. So the other one should be give us maximum. So have you have written this or you have solved, you got the same thing?
Yes, I've written.
You have solved that. Can I clean?
Yes, you can clean.
Okay, good. So the other one, make sure you don't make mistake. Make sure you substitute for this x before you determine. The x are just a turning point. You must substitute in that original problem. Y is equal to -2 all raised to power 3 into 12 into -2 plus 11. So here is 8. Okay, here is -8.
Yes, -8. That's
4
plus
plus 11. That's 27, Abby.
Yeah, 27.
So this is
maximum.
Is it clear?
Yes, it is clear.
And you are happy, your voice is sounding better now.
Exam don't they come, we don't get choice. We have to understand by force. At least whether now we have to write something.
Yes, you must. Okay.
Yes.
So now that we have seen how to do that, I don't want to throw more light here so that when we are solving, when we have time to solve that one, we'll know what to do. This is called total cost. Let's say the total cost was 2x squared minus 3x plus maybe 11. Maybe this, say x is a variable. They can say it's what? Q. They can say, I hope you are following. Any alphabet can be used, whether Q or S or T, anyone. So when you are given this kind of differentiate total cost with respect to Q will give us 4Q minus 3. Is it clear?
Yes.
If I'm also given an exam, total revenue, maybe 8Q raised to power 2 minus 3Q or 3X, anyone they like. If I'm to differentiate this all over D of Q, it's going to give me 16Q minus 3. Is it clear?
Yes.
So, knowledge of the cost has to come in. That if I differentiate total cost, I'm going to get marginal revenue. So this one is marginal revenue in a simple language. That means if I differentiate total cost, I'm going to get marginal cost. Because marginal is changing. Change. Marginal means change. Marginal change in total cost. So that's what we call marginal change in total revenue. So we call marginal revenue. So that's still application. Can I clear?
Yes.
So like I was saying, the same thing. If I know pi is profit. The profit is total revenue minus total cost. That means if I know total revenue function and you are aware that this is quantity times price, and this is already given, and my quantity will be in what is it called? In expressed in alphabet, maybe 10 or 100 minus 2Q. My price, I can say let it be Q also. My total cost will be given. And I express and get some. Are you following?
Yes.
We'll still solve that question, but we're trying to give you an idea of what differentiation idea is all about. So, and So, and the other thing that is not much again, but let me just see before we go for that. Can I clean?
Yes.
Okay. Let's even look at that question. Let's see whether we can even deduce anything. Let me see where it's saying. Okay. According to the question, let's just look at it today. Are you with the question now?
Okay, yes. Should I read it?
Okay. No, I'm reading it. I'm saying.
Okay.
It said, a food manufacturer can sell or refrigerator of a particular type that it can produce. Total cost of producing Q per week is given by 300 Q plus 200. Are you seeing it? That means the total cost function, TC, is equal to 300 Q plus 200, settled. Quantity, the demand function, which is a quantity demanded, is 500 minus 2Q. Now, in this case, the quantity demanded is Q. And for you to get total revenue, it should be total revenue times price, have you?
I guess, yes.
Because total revenue means sales. Anybody's sales should be his quantity times his price, have you? And
Yes.
your price represented by any alphabet you so which. We cannot, because the question has used a Q everywhere, we can still let the price be also Q, and we'll run what we want to run. There is the total revenue function, which will be in expressed in quantity. There will be a total profit function, which will also be expressed in quantity. The question has said, how many units per week should be produced in order to maximize profit? The word of maximize means maximum value. Is that okay?
Yes.
Good. And I say show that the solution to the equation, this particular equation you are seeing, represents the cost function given the same value of Q as in part C. What is the maximum profit available? And that was a quantity. But let's just see whether we can do something to this. Anywhere there's a issue, we can just no. So we're looking at it like this. So you have the question. What total cost function is what? Are you there?
300 Q plus 200.
Q plus what?
200.
Good. That one is settled. Now, demand function, which is Q, is 500, Abby?
Yes, 500 minus 2Q.
Okay. Now, like I said, total revenue should give us quantity times price. And I'm saying, let the quantity still be what it is. And price in this case, let it be Q. Because if I say let the price be, what is it called? If I say let the price be P, there's no change the original problem. Because there are times, if quantity is 10, price could also be 10. Am I correct?
Yes.
And so in this case, they are letting us to understand that price will still be Q, small q. But this one, quantity is capital Q, while price is small what? Q. So in this case, we'll move it this way. That means this will be 500 minus 2Q multiplied by this quantity, which is now price. Our Q is price. Times,
so we can write let price be
small
Q.
And our price also will be X. I haven't seen our P here. We're representing it with what? Q, because the original expression has Q attached to it, and that original expression can also be attached with alphabet X. our price will also be what? X. Or else you will change the idea that total revenue you must state. And our price can be any value, can be any variable, and which could mean something different. Is it clear?
Yes.
Because if you just put P there, nothing, you can't get anything except to want to turn it to partial to complete. But in this kind of question, you must make the alphabet to work, because that total cost, that Q will be X, 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 and our price will also be reading. Write it.
Yeah.
Huh?
Yes.
Okay. Now, I haven't seen that. According to the first question, there was the first question. Find what? Okay.
They said we should find the revenue function and the total profit function.
No, we are taking one by the first one.
Okay, revenue function.
Total revenue function. And I just wrote revenue.
Yes.
So that's the total revenue function you are seeing. So
we can't say it's
so
equals
I'm
to
going to
500
now
minus 2q
expand it.
square.
When I expand it, no, see what I'm doing. I will expand this to 500 q minus 2q squared. That's 500 q minus 2q squared. This is the answer for total revenue function. Is it clear?
Yes.
We have just gotten question A. Total revenue function is 500q minus 2q squared. Because they say find the total revenue value, they can tell us to find total revenue when the quantity is 10 or 5 or 6. We'll have the substitution and find the real total revenue in monetary terms. Is that okay? You're expressing it in either linear function or quadratic function polynomial that the question has presented to us. Is it clear?
Yes.
Can I move?
Yes, you can clean.
So what is in the D? It says what?
This says we should find the total profit function.
Good. And you are aware that profits is total revenue minus total cost. And our total revenue is 500. 500q minus 2q squared. And total cost is what? 300, Abby? Is that?
Yes, 200.
Q and
Total
what?
cost 300q plus 200.
Good. I know that there's a minus there, so you must put bracket so that you now expand 500q minus 2q minus 300q minus 200. So we'll resolve it. This is going to be minus 2q squared plus 200q minus 200. So this is what we call the total profit function.
Wait, Mr. Vincent. There's no 200q there. It's 300.
It's 300q, Navi.
Okay, 500 minus that's 300.
Now, I have to subtract. That's what I tell you.
Okay.
From our addition and subtraction, multiplication of polynomial, very important. So is it clear now?
Yes. So that's the answer. I thought this thing requires some serious solving.
It's not a serious problem. When somebody never do something before, it will be like. So the question says B, total total revenue function, Abi? No, total
Yes.
profit, Abi?
Yes, total profit function.
And this is the profit because profit is defined with the pie. And profit is always total revenue minus total cost. Is it clear?
Yes.
What did they say again?
How many units per week should be produced in order to maximize profits?
How many years?
Units per week.
Okay. Units. How many units are we going to produce?
To maximize profit.
To maximize profit, can we produce in order to maximize profit? Okay. Now, our, so we have a total profit function.
Yes.
Total profit function. We're going to differentiate it. When we differentiate it, we equate it to 0 as usual.
Yes.
Hello. We will differentiate what you are seeing on the board. And at turning point, the Q will give us something that will be equal to 0. Solve and get Q. And Q, when we get give us the result that is involved. Is that okay? So we'll have this. I hope you have written this.
Yes,
Hello?
I have. I have.
Can you hear me?
Yes, I can hear you.
So the C part, pi, which is the profit function, is minus 2q squared, I suppose, plus 200 q.
Yes,
Is
minus
that
200.
like this? So I will not differentiate the pi over dq is equal to
That thing is minus 200.
Mr.
Vincent. That thing is minus 200.
Is it 200?
Yes.
Coming. This is plus 200 q, Abi?
Yes, minus 200.
Okay. It's not 300.
No, it's not 300.
Is it like this? Is it like
yes,
this?
it's 200. Yes.
Is it correct now?
Yes, yes.
We differentiate this one. It will be 200, Abi?
Yes, plus 200.
Abi?
Yes.
A turning point, which we have learned how to differentiate minimum and maximum value. A turning point the pi over the q is equal to 0, Abi?
Yes.
When we equate it to 0, answer will be 50, Abi?
Wait, Mr. Vincent.
No, I'm only asking you. Equate this answer now, equate it to 0. And solve
Okay.
for q. What's the answer?
Okay. Minus 4q plus 200 is equals to 0. Then 200 is equals to 4q. Then q is equal to 200 over 4. That's 50, yes. Yes, it's 50.
Is it 50 or minus 50? Huh?
No, it's 50.
You say?
It's 50.
So the answer is 50 units, Abi?
Yes.
So that has been solved. Is it clear?
Yes, Mr. Vincent.
It's no hard. We have done A, we have done B, we have done C. So how many units per week should we produce in order to maximize profit? 50.
50 units per week.
so that the solution to the equation, the R over the Q, equal to the C over the Q, represent the cost function giving same value of Q as in part C. You know what they are saying?
No.
Now I'll give you small work. You know, we have gotten total revenue,
Yes.
have we?
Yes.
So that total revenue, help me differentiate it. That total cost, help me differentiate. Let me see what you are getting. Differentiate, you know, the total cost function is with you. Sorry, total cost function is with you. Total revenue function is also with you. Now, differentiate the total revenue, get the value. Differentiate the total cost. I'm waiting. Because I made this up now, make you to try this one. Yes.
Wait, the total revenue and the total cost.
We have total revenue function that we have gotten. As in,
Okay.
is that not A?
Yeah, that's A. Then the total cost is just that
Differentiate.
normal question, Abi.
Total cost
You didn't
one that
get
is already
total
there.
cost function. Okay, okay. So that would be
No,
500
they have
Q
given us.
minus 500
Sorry, I do the
Q
two.
minus 2Q squared. That will be 500 minus 4Q. Total revenue and total cost will be 300 plus 300 Q plus 200. That would be 300. So total revenue, I got 500 minus 4Q. Hello? Hello? Huh? Hello? Hello, Mr. Vincent.
Are you true?
Hello?
Have you gotten the answer?
Yes, total revenue, I got 500 minus 4Q.
Okay, that means total revenue was a 500 Q that we got before.
Yes, minus 2Q squared.
Q squared. And when you differentiated that, you got the Q, you got 500 minus 4Q like that.
Yes, 500 minus 4Q.
Okay, the total cost was, is it 300?
300Q plus
Q
200.
minus 200.
No, it's plus 200. Oh.
Okay, plus.
So I got
So when you
300 for that one.
differentiated this, you got what?
300.
300.
Yes.
Okay. Then I say, you know, this is what we got here, Abi?
Yes.
And this is what they give us there. They say we should equate these two together. The first one is 500 minus 4Q, Abi?
Yes.
The second one is 300. I should equate the two and find Q. What do you have?
Okay, equals to 300. That would be 500 minus 300 is equals to 4Q. 200 is equals to 4Q. So 200 over 4 is equals to 10. So 200 over 4 is 50.
Is it what we got before?
Yes, that's what we got before.
That means we know book with that.
So wait, you mean for that unit? Is that the answer?
That's what they said. They said we should solve it in such a way that it will be equal to what we got in CRB.
Okay, yeah, okay. That means we're right.
Show that we're only showing a kind of problem. Show that the solution to the RDQ, which is total revenue, equal to the CDQ, represent the cost function given the same value of Q as in part C. Abi? Is it clear? Hello?
Yes, it's clear. Sorry, I think it's network. It's clear. That means you are right.
Yes. The last one is E. What is the maximum profit? Remember that when we solve maximum profit, you know, we got Q, Abi, as 50. Carry that Q, go to the total profit function, Abi.
Yes.
Slot in 50. Whatsoever you get is the maximum profit. Just like when we are differentiating Y, when we get X, we substitute. After substituting, if it's positive, we know it's maximum, Abi.
Yes.
If it's negative, we know it's minimum, but there can be that kind of situation. So, okay, total revenue, okay, total profit. What is our profit? Profit function. What do we get? Hello?
Profit function.
Huh?
We got
profit function. What do we get?
We got minus 2Q squared plus 200Q minus 200.
2Q. Are you sure?
Yes.
Okay. Q squared minus.
We got minus 2Q squared plus 200Q minus 200.
Minus 200, like this. Now that means wherever I see X and Q, Jerry, I put 50. Raised to power 2 plus 200 times 50 minus 200. Formal indication. 50 squared. It's a lot of value. 50 squared.
25.
25. That will be minus 5,000.
Minus 2. Yes, minus 5,000. Plus.
And this one
200 times 50.
This 10,000.
Yes, 10,000. Minus 200.
Are you sure this one is wait. 50 times 50. 25. 00. Okay. So this is minus 5,000. Agreed?
Yes.
Did you press calculator? 50 squared. Is it 25?
Yes. 25, yes.
So this one is minus 200. This is 5,000, have you?
Yes.
Minus 200.
Go for it.
For it. So this is the maximum profit. And you can see it's positive, have you?
Yes, it's positive.
So which means that is the maximum or the maximum profit. Is it clear?
Yes.
So if you see that kind of question, that's how to handle it. And these are the kind of things they can give you. Just understand what we have. This is still application of differentiation. Have you seen that type of application? I want to look at the other one, which is actually partial derivative. We have seen a little of that partial, but not the total. So implicit function can be likened to partial, but the real partial is actually quite different from that. And that's what business students use regularly in solving some questions. For this one, total cost, total revenue, and so on. You need to remember that. Are you true?
Yes.
Good. The next thing here is, let's go on this one. Partial derivative. Let's just take 2 questions and give you something to try. Partial derivative. The word partial is very clear. That means you can have more than 1 variables in it, and you're expected to solve. Question 1. But this one. I have function yx. Let's start with that small one. X squared y plus x squared plus y squared. You know, this wants to resemble that one, a bit partial implicit, Abby.
Yeah.
But that implicit is always written first, equal to 3 or equal to 4, equal to 5. But this one, there's a function, f. And there are 2 variables involved. Examination question can say, find the f, the x, the f, the y. Can you solve this?
And
Okay, let's leave. What it simply means that you are expected to differentiate the f, the x. Means that when you are differentiating x, all those y are going to be constant. The y will be constant. I know that anything is constant to be 0, right?
yes.
But your knowledge of a product rule is also important, especially this one that has the 2 together. Have you copied?
Yes.
Okay. So to solve the first one, let me just manage here. The f, the x. This first one, x squared and y, we'll just differentiate
So
x with y.
x, y,
Plus, we differentiate x, which is 2x. This y will be constant, which means it's 0. And that is the answer to that question. That means we're looking at y as a constant.
Okay, let me try the other
when
one.
you look at y,
Let me try
okay,
the
try
other
that
one.
out.
The
Y.
f
So
over
now
the y
that one you are
will
making
be.
x squared as constant.
So this x squared, is it automatically 0?
Not that is 0, but there's how you will solve it, it will become 0. But not everything will be 0. Like so my own. Okay. This one will be like product. First is s squared plus second. Differentiate the second, it will be 0. Everything will go away.
It will be just
So
2y now.
This one is your knowledge of product you are applying. Knowing fully aware that the other one that you are not using is a constant. That same way we did the other one, but it's just that the other one is constant. Because it's constant, it will be 0. And the 0 will affect the other part. You know, when we are doing implicit function, we're saying this plus this, we use everything and put the y ds. But this time around, because you are doing y, everything about x will be constant. And when you are dealing with constant, you know it's going to be 0. And the 0 will affect something. But copy this, I will just show you something so that you can understand
I've written it.
Let me now show you this. This is what I'm saying. This is x squared and y. This is f. We are saying that this, if I'm doing the y, the f, the y.
Why?
It means that x squared is constant. You treat these two numbers, two letters, as product rule. How do you go about it? Watch you. First is S square. Second is, I've taken S square. Then I'm going to differentiate Y. And when you differentiate Y, you get 1, Abi?
Yes.
Plus, when you now take
Plus x squared
Y, when
plus
you take
2y.
Y, you now differentiate X squared, and X squared is a constant, you know it will be 0.
Yes.
The whole of this is gone. This is now your answer. So instead of you doing that, what we normally do is that we are not looking for X squared. This is what we're looking for. Differentiate this Y is 1. 1 times this is our answer. Did you get it?
Yes.
Because this one is gone. Because there will be a constant there that will be 0. That will make everything go away. So you don't need to bother yourself with that stress. This is Y. Differentiate this Y, is 1.
Okay.
1 times what was attached to it will still remain.
Okay. So is
Yes,
x squared 1 plus x squared plus 2y.
So that means plus 2y, yes, 2y. It will just be 2y. The other one is already 0. So your answer will be this. X squared.
0. No, it is x2y plus x squared. So that x squared in the middle, it will still be x squared now because it's x.
No. We are differentiating y and b.
Yes.
What's the problem? Shabi is x, this y squared plus x squared.
It's x squared.
This is x squared. Another one is y squared b.
Y squared, yes.
We are dealing with any place there is y. That's what we're after. This one is 0, abi?
Is it 0? You said it to remain. We'll write it like that now.
Y. See. This is the y. Does this one have y?
No.
It doesn't relate to y now. So this x squared now will be constant because we're not looking for x. But it's just that this one is y. It's attached to something. That's why it's coming together. It will be there. But this one does not attach to anything. It's 0. But this one is ordinary y. It will be 2y. So the answer will be x squared plus 2y. So that one we are not looking for will be constant.
Okay.
Is it clear?
Yes.
Good. Let's see another one you can try. Let's see another, right for me. Alphabet U, small u. Are you there?
Okay. Yes.
Small u equal to xy squared. Xy raised to power 2. Are you there?
Yes.
Plus xy plus xy minus x squared. U equal to xy squared plus xy minus x squared. Are you there?
Okay. Yeah.
Find Roman figure 1, the u, the x. The u, the x. Roman figure 2, the u, the y. Let's see what your result will look like.
Okay. Okay. du dx is 2x squared plus minus 2x.
Okay. You say du ds is what?
2xy minus
2xy.
yeah
Okay.
minus
Uh-huh.
2x.
Minus s squared.
No, minus 2x. So
Okay. Okay, try the second one. Let's find out.
okay. I just got 2xy for that one.
2xy. According to the question, u is equal to xy squared.
Yeah.
What else?
Plus xy minus x squared.
Plus xy minus x what?
X squared.
Okay, like this.
Yes.
Now du dx is equal to this one. Don't need y. Y is a constant, so it's going to be y squared. Abi?
Yeah.
Because if you differentiate that x is 1, y times the constant is there, plus this one is sy, differentiate x to be y. That one is constant, it's gone, it's 0. Is that what you got, the first one?
No,
What did you get?
but you said that it's because they come together. X and y come together. That's why
Yes.
you just write the y like that.
Okay.
So why
I
did you
don't
throw
do
the
this.
x away when it's joined together?
Did I trace away? Let me see whether I didn't make a mistake with writing the question. Let's see how the question is. Oh, we're differentiating x, Abby.
Yes.
So this is x, Abby. Don't mind me, don't mind me. I even forgot. I thought that one is not. So it's going to be minus 2x, Abby.
Yeah. Is it minus 2x?
Hello. It's correct now. You are correct. dy.
We are
But that of
differentiating
y.
x, Mr. Vincent. X.
Which one is x?
The first one is the u dx.
This one is dy now.
That answer is not correct now.
Say the first one.
Yes. It's not x
No.
we are differentiating.
Wait. We are differentiating x, Abby.
Hmm.
Is there x here?
Yes.
So let's go. Differentiate x is 1, Abby. 1 times the constant. Constant will not go away. This is also
Wow.
xy. Differentiate the constant. Constant will not go away. But we're talking with x, so differentiate x squared to be 2x. This is the right thing. The one is not like that. Something is wrong. Now for y, this one is y. In this case, x is constant. So we're having 2y with x. Because the constant will stay like that with it, plus by differentiating y. Differentiate this y, it will be 1 with the constant. And this one is 0 because it's a constant already. So the answer for this one is 2yx or 2xy plus what x. Is it clear?
I don't understand though.
Okay. But you understand the first one?
Yes. So if you can't
do.
add the 2xy for the first one, why are you adding it for the second one?
Did I add anything?
Yes, now you wrote 2yx. Are we not differentiating y?
We're differentiating y now. Why is it if you differentiate y? That means 2s and 2y, Abby.
Yes, it's 2y.
Are we going to throw away the constant? Constant will still remain now. But look at
You
it.
said it is 1.
Wait,
Is 1.
wait. No, not that one is 1. What? The first one is the u dx. X. So we're looking for. Is there x here? Yes.
Yes.
Differentiate that s. Is it not 1?
Yes, it's 1.
1 times y squared. Is it not y squared?
Yes, it's y squared.
Because it's a constant. Constant we don't do anything to them. It will stay there attached to the problem. Now, the second one is xy. Differentiate x is 1. 1 times a constant will still remain. And this is s squared. Differentiate s squared is 2s. This is the answer.
Okay, then the
The
y.
second one, we are to differentiate y. That means our x is constant.
Yes.
Now, differentiate y squared is 2y times a constant. Differentiate y is 1 times a constant. Differentiate this because this one is a constant now because we're dealing with y, and that is why it's 0. Is it clear?
Yes.
We can't throw away the constant. Okay, try one more. Let's see whether there will be a change. Let's see how this one will go. Are you ready?
Yes.
This one will be, let's just make it quick. Z, as in Z. Z is equal to x raised to power 3 minus 5y raised to power 10. Are you there?
Yes.
Find the Z, that's the Z over the x. That's Roman figure 1. Find the Z over the x. Roman figure 2. Find the Z over the y. What do you have?
Yes.
Let's see how you look at this one.
G and the x. To x, that will be 3 x raised to power 2 minus just 1. And the z over the y was to be 50 raised to power 9. Okay, dz dx. I got 3x raised to power 2 minus 0.
Okay. And the second one go?
Dz dy. I got just I think it's 50y raised by 9.
Okay. Is that all?
Yes.
I want to find out whether you are correct there. So the question was Z equal to x raised to power 3, Abby?
Yes, x raised to power 3 minus
Minus 5
5y
raised to power
raised to
10.
power 10.
So the Z over the x, this x already is going to be 3x squared. Is there any s here?
No.
Is it what you got?
Yes.
Good. The other one, the Z over dy, this constant is 0. This one, because there's a y there, become 50. Y raised to power 9, Abby?
Yes.
So final answer is minus 50. Y raised to power 9. You must work on this thing. Seriously? So let's take another one. There's another small one here. A small one. It said find the f, the x. Find the f, the x. Bracket open, 1, 0, close the bracket. Find the f, the x. Bracket open, 1, whole number, 0, close the bracket. Are you with me?
Yes.
Where fx, function of x, where fx equal to x raised to power 3, x raised to power 3 plus y raised to power 3, x raised to power 3 plus y raised to power 3 plus xy.
Okay.
Are you there?
Yes.
The first step is differentiate with respect to x. And the question could also be differentiate with y, but let's do s and see how it works. See what your answer will be.
2 plus 0 plus y. Okay. 3x raised to power 2 plus plus xy. Plus
sure?
y.
Plus y. Good. So the answer should be 3x squared plus y. And that one whole number and 0 they are talking about there means that after differentiation, whatever is cx, you put 1. Whatever is cy, you put 0. Can you do that? Do substitution. X is 1, y is 0. So that you can find the f.
All right. The answer is 3.
The answer is 3, Abby.
3.
Good.
Yeah.
Good. So that's how to do it. Can we say you have gotten it?
Yes. I'll go back to it, but yes, I've gotten it.
You can do it. Good. So let's go on to the next. The next you are scheme that you sent. And I see, okay, let's see what you say.
Yes.
Okay. But there is matrix in what you sent the second time. Okay, there's no more matrix. Okay, let's forget that. So partial derivative, but there's integration, Abby.
Yes.
Okay. So let's integrate, because one thing about integration, your knowledge of differentiation is carried to integration. Is there anything like Pythagoras theorem?
In the course outline.
What you said there, I saw Pythagoras. I don't know whether it's Pythagoras. I don't know how that they enter. Is it part of it?
Pythagoras
because what you said before that I know was calculus, integration, general rule, definite integral. You're not even looking at indefinite.
Even definite. I'm saying it though, it's like matrices is there.
Because I know there's maths in the past questions all around. Yeah, okay, we'll do it. There's maths plenty because I know that one. But no other. Let's go to integration because differentiation and integration are all calculus. Are you following?
Yeah.
So let's integrate. It's just a little bit opposite. It's not something difficult. It's just you follow the rule also. Is integration. Integration. Opposite of differentiation. So integrate. ax raised to power n with respect to x. This symbol you are seeing in front is what we call integral function or integral symbol. Integral symbol. There are two types of different integration you can talk about, definite and indefinite. What I've written here now, I can also write the y, the what, x is equal to ax raised to power n. This and this are the same. Examination question can say, if this is this, whether it's written like this, if it's written like this, fine. If it's written like this, or if it's written like this, they mean the same thing. If dy dx, which is differentiation that we have just finished, is like that, then our y will be equal to a x raised to power n. You will increase the power by 1, divide by the new power, plus k. K is arbitral constant. Remember what we are doing now is indefinite integral. This is what we are looking at now. There are two types of integration. We have indefinite integral and the definite integral. What we are looking at now is the indefinite. The one, this indefinite will have a constant, and this indefinite will not have any power in the integral symbol. This is the integral symbol. That's the integral symbol. There won't be any power on top of the integral symbol. There won't be any power down of the integral symbol, which we normally call uppercase and lower case. But this one is just like that. So there's no power. So anytime you see it like that, you know it's indefinite integral. This one will always go with an arbitral constant, K. Arbitrary constant, K. A-R-B-I-C-R-A-R-Y, arbitrary constant. I'll let you, I'll throw more light so that you can understand. Is this clear? This is the formula. To increase the power and divide by the new power plus arbitral. Are you still there?
Yes,
no, it's
I'm
not
here.
difficult. Don't worry, it won't be difficult. You'll see what I'll do now. But
All
just
right.
use the formula. We increase this n, and we add 1 to that n, and our new power is n plus 1. We divide it that. I'll show you. Can I click the button?
Yes.
Put it down in your notes.
Yes, I've written it.
Good. This is why we put that constant. If I have this 2x squared plus 3x plus 4, if I differentiate this, I'm going to get 4x plus 3 plus 0, right?
Mm-hmm.
If I want to integrate this, because this is what I got, so integrate it.
So wait, you differentiate first before you integrate?
No, we're just showing you why that K came. But the knowledge is important. You must know the truth. You know, this is the answer I got now, Abby.
Yes.
Now the question from that answer, say I should integrate. The question is simply saying I should go back to this. How do I go back? So now be y, 4x This raised to power 1, Abi.
Yes.
It will now be 1 plus 1. Divided by the new power. Plus. This 3 you are seeing means 3 raised to power 0. You add 1 to it and divide by 1. But how this number will come back is difficult, Abi.
Yes.
So because it's difficult, it's okay. Let's represent it K. Because the constant we can't get, except the additional information is given for us to arrive at that. If you check this one now, this first one, if you check it, if I divide it, it will give me this, Abi.
Yes, 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 yes.
If I have the second one too, I will get this. But that third one cannot be cut in because we need additional information. Therefore, we put K. So that is the purpose of that arbitrary constant in indefinite integrals. Is it clear now?
Yes.
So we'll go forward, take it back. That is the purpose. So you must understand differentiation before you talk about integration. So with this first question, moving on. Can I clear?
Yes, you can.
Good. Now, the first question for today is that we should differentiate. This S squared. That ds means with respect to x. Integrate x squared with respect to that is ds you're seeing there. So to solve this, I will say y is equal to x squared plus 3 plus k. That's the answer. Alpha. 2 plus. The power is 2, Abi. You add 1 to the 2, become 3.
Oh, is this another question?
Eh?
Is this another question?
This question 1 for now. Question 1 says integrate x squared with respect to s. That's the ds. Solving it will be y equal to power 2 will be increased by 1, which is now 3, and you divide by 3, and you attach k. Some can even use c, doesn't matter. What matters is a constant attached to it. That's the answer to question 1.
Yes.
Is it clear?
Yes.
Integrate x raised to power 4 with respect to s. Y will be equal to x. Y will be equal to x raised to power 5.
X raised to power 5 over 5 plus k.
I hope that's not.
No.
Okay. We'll take it gradually. Number 3. Integrates 1 over x with respect to x. You know that this one is something as you know it's the same
X
thing
raised
as
to
this.
power minus 1. Yeah.
But you will agree with me. If I add 1 to minus
1 is going to be 0. Yes, it's 0.
If I add 1 to it, it will be 0. And
yes.
when you add 1 to it, when you add 1, it becomes 0. You will discover that if you try to differentiate it, you know it will be 0. Divide by 0, right?
Yes.
If I add 1, if I want to do it now, so okay, y is equal to minus 1 plus 1 divided by 0 plus k. This will be meaningless, Abby.
Yes.
Because if you divide by 0, will anything come out?
No.
So anytime you have this type where the denominator will be 0, the right answer to that question will be y equal to log of x in base e, base e plus k, which is the same thing as y equal to ln x plus k. That's still the answer. So anytime you have 1 over x, it's going to be logarithm of x in base e, which is also known as natural log of x, ln x, or log x in base e. So anytime you have this kind of differentiation, where we have 1 over x, where the result will involve us dividing by 0.
Okay.
The answer you should write to be natural log of 1 x plus k. Is it clear?
Yes.
So that means that there is no way this can be the answer. From here, we have the answer. Another one, can I claim?
Yes.
Another one will be integrates. That should be number 4. Abi?
Yes, number 4.
Or 3. Okay, so number 4, 2x 3, 2x3 plus 3x squared minus 1 with respect to x. We still go the same way. 2x raised to power 4 over 4, 3 raised to power x3 divided by 3 minus 1, x raised to power 0 plus 1 all over 1 plus k. Is it clear? Our y will be x raised to power 4 over 2 plus x raised to power 3 minus x plus k. And that is the answer. Remember that when you see a constant, every constant simply means there is x raised to power 0 attached to it. So by the time you add 1 to it, we're going to arrive at an acceptable answer. Is it clear?
Yeah, but x raised to power 1. Okay, it's x. But it's 1x raised to power 1. X raised to power 1 is x.
X raised to power 1 means x now.
Yes,
You know,
okay.
so 1 times anything, will it change? 1
No.
times it was x raised to power 0 before. So I'll wrote that one so that somebody will understand. 1 is
Okay.
Is it clear? So we'll look at another one. Number 5, integrate 2 2 into 2x minus 3 all raised to power 2 over 3 with respect to x. And so you can see that what is in that bracket has a power. And it reminds us of a little idea of composite rule, have you?
Yes.
In differentiation. But because this is what is it called? This integration, the idea will be quite different. And this is what I'm going to do. We'll go this way. That 2 you are seeing there is a constant. Let it be outside there.
We can't multiply it.
Is that?
You can't multiply it.
They can't, I don't understand.
Like, you can't make it 4x minus 6.
No. Okay, we can expand. There's a power on top now. The power is 2 over 3, Abby.
Okay.
You can expand there. You have to bring it out. It's a constant. And because it's a constant, it will just be outside there, stay doing nothing. But the one that will work is this one, 2x minus 3. The one we are doing, what is it called? When we are doing composites, we'll bring the power down, Abby.
Yes.
But this differentiation we add 1 to the power, divide by the new press calculator, 2 over 3 plus 1, because that was the new power.
2 over 3 plus 1. Okay.
Yeah, click on it there.
No, it
Is
did.
one whole number 2 over 3, Nabi?
Yes, I'm coming.
Oh, yeah.
So, what's that thing? 2 over 3 plus 1. 5 over 3. What of that dx? Isn't it okay?
That DS, which one is DS?
That one at the end.
No, that DS is with respect, letting us know that the problem.
Beautiful. Everyone.
So,
Yes, that's the answer now. You can
good.
clean.
Now, no, I have not finished. Now,
I'm not done. Hey.
Look at what's in the bracket. What's in the bracket?
What's in the bracket?
What's in the bracket?
2x minus 3.
You know, when we are doing composite rule, when we raise to the power, bring the power down and subtract 1. What we normally do is that we differentiate what is in the bracket and multiply by it. Now I'm going to differentiate it. What you are doing today. You differentiate what is in the bracket. You will get 2 again. Hello?
I can hear you.
Differentiate what's in the bracket, we get 2, Abby.
Yes.
Opposite of differentiation is integration. So my differentiation is 2. The opposite is what? 1/2. To make it integration, then plus k. So you understand?
If you integrate 2x minus 3.
If you differentiate what's in the bracket, you get 2. So make it integration, you turn it upside down, which is half.
Okay.
That's what I do. Now you can see that knowledge of my differentiation is still coming in. If one does not differentiation, it can work. So what's in the bracket is 2x minus 3. Differentiate integration, which is half. And the 2 down, 2 up will go away. And we're left with 2x minus 3 all raised to power 4/3, 5/3, all over 5/3. Finally, I can turn things upside down. 5/3 becomes 3/5 into 2x minus 3 all raised to 5/3 plus k plus k. And that's the final.
Vincent, I don't feel do this one for this one. I don't go answer if I say I'm for exam.
We don't leave them.
I could just leave them.
Leave them is easy. This 2 that is there. This 2/1. This 2, wait. This 2/1. Who send you, Abby? No, nobody. It's very simple, Jerry. So 2/1 times 1/2 is gone, Abby.
Yes.
That numerator is now 2/3 plus 1, which is 2x minus 3 raised to power 5/3 power.
Where's
That's
power
5/3. You know this 2/3 plus 1 power now. 2x minus 3 will be raised to power 5/3. And this 5/3 that is denominator, we'll turn it upside down and become 3/5. Because it is numerator divided by 5/3. Change division to multiplication, become 3/5. And this will be our final answer. This one. 3/5 into 2x minus 3 raised to power 5/3 plus k.
Okay. All right. No,
The manager. Manage it. Oh yeah, try. Let's see whether you can try this small one that does not have too much stress. Let's see whether you can try it. This one does not have fraction. Just follow that same procedure I just did now. Number 5, you get the same result. So let's see. Can I do?
yes.
Okay, so try this. Let's see. Maybe because I'm the only one doing it, that's why it looks as if it's hard. This is raised to power 2. So at least this one is no fraction. Increase the power, divide by the new power, multiply by the inverse of the differential coefficient of what is in the bracket.
Okay, I think it's that one that I don't like that one that we did now. It was 2x minus 3. How did we get 1/2?
So okay, that 1/2. That's what I'm saying. What is in the bracket was 2x minus 3.
Yes.
So you are multiplying by the inverse of the differential coefficient of 2x minus 3. Inverse. That means what is in the bracket is 2x minus 3. If you differentiate it, you get 2, Abby.
Yes.
The inverse of 2 is 1 over 2. That's what you multiply it by.
As
The same thing with this. Increase this 2 by 1, divide by the new power, multiply by the inverse differential coefficient of what is in the bracket. When you differentiate, turn it upside and multiply by it. That's all. Because if you multiply by the differential coefficient, it will be as if you are doing differentiation. But if you multiply by the inverse of the differential coefficient of what's in the bracket, it makes it differentiation. Because it makes it integration. Because integration is the inverse of differentiation. Is it clear?
Yes.
And
Okay.
there's hope. There's hope.
All right. I got some. Let me try. I got 3x minus 2 in brackets raised to power 3 over 3 plus 1 over 3 plus k.
Over 3. No. Okay, 0. Okay. Okay, 3, yes. Okay, this one is 2, Abby.
Yes.
Okay, I continue. No.
3x minus 2 raised to power 3 over 3 plus 1 over 3 plus k.
Good.
Now where?
Yes, what's final answer now? I get the final result.
Okay.
So now be 3s minus
3.
something raised to power something all over the total result plus k.
That's 3 into bracket 3x minus 2 raised to power 3 plus
over.
I brought the 3 up.
3 up, then that 3 will be down again.
Yes. Okay. 3 over 3. Yeah, 3 over 3 plus k.
So what's the answer?
3 into 3x minus 2
What's the final answer?
raised to power 3 over 3 plus k.
Raised to power over what?
There's no over. 3 into 3x minus 2 plus k.
You add these 3, Abby.
Okay, I brought it up already now.
Divide by 3.
I mean the final answer.
But the final answer should be what?
3 brackets 3x minus 2.
So it's not 3 bracket, it is bracket 3s minus 2 raised to power what?
Raised to power 3 plus 1 over 3 plus k.
No. Times.
Is it times? Okay, it's times.
1 over. Yes, now you multiply by the inverse of the differential coefficient, then plus what? Okay. Then our answer will not be 3s squared, 3s minus 2, all raised to power 3, all over 9, plus 3.
Where do we get 9?
So this is 3.
Yes.
The denominator is 3. This is also 3.
All right.
Oh yeah, make I change the question. This is part 2. Make it part 3 and try. Let's see.
Okay.
That's part 2. Let me part 3 and do a good job like this and make it fine. We must fast to be able to so that when we finish this, we'll be talking about matrices. And I believe what remains not much. If after the matrix, we just do queuing line, Abby. Hello?
Yes.
Maybe after matrices, we'll do queuing model. That's all, Abby.
Yes.
So let's say 2 more topics. This integration, we should finish it.
Okay, continue the next one. Okay, where's the part 3?
Okay, this one, I say this one. That same question. All raised to part 3 now. The one you just did now was part 2. I tried this one.
All right. All right. 3x minus 2. I got 3x minus 2
3x
power
minus
4
2, raised to power
4
over
12 plus k.
Good. I'm doing well. That one has gone. Let's see another small one. This one should be also small. X squared minus 1 all raised to power just 2. Try this one too. Let's see whether we can leave this matter.
That's why I'm being. Okay. I got x raised to power 2
Yes.
minus
what?
1.
Wait. S what?
Okay, is it 3? Is it x squared now? X squared
S squared. Okay. Bracket open.
minus 1
Okay. Raised to
raised to
power
power 3 over 3.
Are you sure it's over 3?
Yes, it's over 3 now.
What else again?
Plus 1 over 2x.
Okay, plus or times?
At times 1 over 2x plus k.
Good. Final answer will now be we'll join it together. Multiplication for denominator, multiplication for numerator plus k. Are you there?
Yes, I'm here.
Yeah, now answer never come. At least you have
The answer never finished. Jesus.
And so add it together now. You have not joined the thing together. So that
Okay, 6x.
That's what I want
X
to
raised to power x squared minus 1 raised to power 3 over 6x plus k.
You are not talking. You are doing okay. Let's see another small one. Already They don't think because this business, they can't be talking about this sine, cosine, tangent. That one doesn't cosine them. But I don't know. Were you taught anything like cosine, sine? I don't think this business. The more of the application of this business should be like what we did now, total cost, is that, those are the kind of thing they will give you more. And that's what they will do. But applying the other one, no, it's not science what I do. So let's see how we can integrate this one before we move into definite integral. When you see something like this, 1 minus x all over x raised to power 3, and you're asked to differentiate, what will you do? Let me just hear. What will you do if you have to do this? You have to do something like this. What would be your idea?
Okay, it's raised to power 1. That would be, I would say 1 minus x over x raised to power 3 over 2.
Over 2. Where do you see 2? Is there anything inside? Okay. The best thing is to remember knowledge of fraction. Very important. Or you start solving. Do it like this. All over x raised to power 3. You know, that's the meaning of that fraction. If you find LCM, you get back to that, Tadi.
Okay, yes.
If you find LCM of this, you'll get what's on top as 1 minus x over x raised to power 3. So do it like that first. And remember law of indices. That will be minus. This s will cause x squared to be like this. And this is the question turned properly like this, so that you can start solving it the way we have been doing, 1 by 1. With y.
Is it minus 3, minus 2 or minus 3?
No, minus 2 is that one, because this x is on top.
X.
This x will divide and will reduce it, right? So start doing it 1 by 1 as usual. Increase this 1 by 1, it will become x minus 2 divided by minus 2. Minus, increase minus 2 by 1, it will be minus 1 all over minus 1.
Minus 1.
Plus k.
Plus k.
Is it clear?
Yes.
So that will be the answer. But the only thing that will happen is that middle is we're going to have minus 1 over 2 x squared, 1 over 2 x squared plus 1 over x plus k. You know that the minus 2 is down, Abi. That will be 1 over minus 2. And the x raised to power minus 2, law of indices will go down, 1 over x squared. So they are now seeing minus 1 over 2x squared. Plus, because the minus down will divide minus that is at the middle to become plus. So minus times minus or minus divided minus, whichever one. Then x raised to power minus 1 inverse will come down. Is it clear?
Yes.
One small example so that we can at least start matrices. There's no much here. Let's see this. This is definite. Just with few questions we can know that. Definite integral will be something like this. Maybe here is 4, here is 2. We now have 3x minus 1 with respect to x. Are you there?
Yes.
What definitely means is you quickly solve. There's 3x squared over 2 minus x, Abby.
3x squared over 2
plus k. Abby. If you differentiate 3x, that means 3x squared over 2, Abby.
Yes.
Sorry.
Differentiate, I mean integrate.
It means to add 1 and divide by new power. And
Yes,
this is ordinary minus 1 now. This is ordinary 1, which is a constant, which will become to x. The question mentioned, because it's a definite integral. Because it's definite integral.
But how is this 1x? 1 raised to power 1.
1s raised to power 0. You know it's a constant, Abby. That's 0 on top. Add 1 to it and divide by 1. It to be s.
1 raised to power 0.
You know, this is ordinary one whole number.
Yes.
And this is the meaning.
Okay.
Is that not the meaning? So
okay.
add 1.
Okay.
You see the way I draw line there?
Yes.
I can draw it like this also if I so wish. Anyone is okay.
Is that divided by 4 over 2?
No. What I'm doing is, you can do it like this. Minus x. This is what we got when we differentiated, Abby. Sorry.
Yes.
When we integrated, this is what we have. So because there is a power on top, power down, which makes it definite integral. Are you following?
Yes.
And that means we're going to get a value. That 4 on top is the upper case. The 2 down is the lower case. What that upper case and lower case all about is what they call substitution. Is it clear?
Yes.
Wherever you see s, you put 4, you get a value. Whenever you see s, you put 2, you get a value. The value you got from 4 and the value you got from 2, you do a subtraction. The first one minus the second one. That's the answer. Is it clear?
Okay, yes.
After integrating those power up and down, upper case 4, lower case 2, you do substitution. Wherever you see s, you put 4 and you get the value. Minus, wherever you see x, you put 2, you subtract. So, but have you copied to this point?
Yes.
Okay. So if you have done that, so what I will just do is 3 into 4 all square over 2 minus 4. This is the first one. Minus result of 3 into 2 all square over 2 minus 2. That's all. And this one will give us.
Wait, though. 4 raised,
okay,
4 raised to power 2 is 16.
48, Abby. 16 times 6, 48, Abby.
Is it times 2? 16 times 3.
Yes,
4 square.
16,
48 divided by 2.
That's 20.
That's 24.
4. Minus what? 4. Into 4. 6 minus 2. Agreed? 20 minus 4. Answer is 16 square units. That's the answer.
Okay.
Are you with me?
Please, just a second. Okay.
All right.
Okay. So equals to
Is it clear?
20 minus 4.
Yes.
Yes.
So that's how to do it. That's definite integral. And if we may look at some small, I don't think they even do teach up to that level. No, I don't think. Did they do anything area under curve?
No.
I don't think so. It's okay. Let's leave that one like that. Let's now move into matrices. Abi?
Yes.
If you have the book, I don't think chapter 20. You have my book, no? You have not got it yet?
No, not yet.
Okay, let's write it. Matrices. Matrices here is, how will I call it? Plural. While matrix, this one, IS, this singular, RIX. This singular and this plural. So as far as matrices is concerned, we have different types. Are you ready?
Yes.
All right. A matrix, plural is matrices, like I just said. A matrix is defined as a rectangular array. Rectangular array arrangement, whichever. Rectangular array of elements.
Okay.
Or a rectangular array of elements, numbers, symbols, or expression. Elements, it could be numbers, it could be symbols, it could be expressions, arranged in rows and columns. Arranged in rows and column. Rows and column. Rows and column. Is it clear?
Yes.
And we have different types of matrices. We have 2x2 matrix. We have 3x3 matrix. So these are examples of matrices. Examples of matrices. We have maybe A, B, C, D. This is a 2x2 matrix. The horizontal arrangement is a row. This is the rows. This is the columns. Is it clear? Rows and column. We may have 1, 2, 3, 4, 5, 6, 7, 8, 7. This is a 3x3 matrix. Matrix that has 3 rows and 3 columns. Any matrix that has equal row and equal column is a square matrix. Square matrix. Is it clear? Are you still there? Hello? Hello? Can you hear me? Tommy? Are you still there? Can you hear me? So we have 3 by 3, 4 by 4, 5 by 5, 6 by 6, and so on. Are you there? Have unit matrix that has 1 all around. In the rows, there's 1. In the column, there's 1. We have identity matrix that has 1 at the major diagonal, y0 x square. Can you hear me? Can you hear me?
Yes, I can hear you now.
Okay. Now, what you see on the board, I said the horizontal arrangement is the rows, while the vertical arrangement is what? Columns. What you see on the right-hand side of the board is that you have 3 rows and 3 columns. So when there are equal rows and equal columns, we say there's a square matrix. Abi?
Yes.
We have another one we call identity matrix. Types of matrices. Identity matrices. When we say identity matrices, we have the type of matrix like this. We have, when you have a rectangle or square, we have what we call diagonals. So 1, 1, that 1, 1 is in diagonal. That 0, 0 is in diagonal. So we have 2 types of diagonals here. One is major diagonal and one is minor diagonal. So the major diagonal is this one that has 1, 1, 1, 1. This one that has 1, 1 is the major diagonal. So when there is 1 in the major diagonal of a matrix and 0x square, we say is identity matrix. This is a very good example again. This one is a 3 by 3 matrix. 1 in the major diagonal, 0x square. That is what we mean by identity matrix. We have a matrix of different types. We have 4 by 4 matrix, 5 by 5 matrix, and so on and so forth. And you will get the same word result. We'll have another matrix like this, something like this. It's still a matrix. That means 3 by 2. We mentioned role for talking about color. Is it clear?
Yes.
Hello? We mentioned role
Okay.
before color. That means a 3 by 2 matrix means 3 rows, 2 columns. That is what it means. But these are some things you need to just understand. Apart from all that, the next thing we are looking at is how to add, how to subtract, how to multiply how to multiply matrices together, and how to add them. So we're going to take some questions and see how to calculate addition and subtraction of matrices. I haven't told you what matrix is all about. That is a summary of that. What is role, what is color, what is identity matrix, what is 2 by 2, 3 by 3, and so on. Is it clear now?
Yes.
So the topic now, addition and subtraction. Addition and subtraction of matrices. That's the subtopic. Addition and subtraction of matrices. Addition and subtraction of matrices. We'll take a question. Given P 5 minus 2, 1, 4, comma, matrix Q. We have 8, 4, 6, 8. Matrix N, we have 1, 3, 4, 1, 3, 4, 5, no, 3, 5, 4. So we have 7, 6, 7. We have matrix R minus 1, 3, minus 6. We have 2, 4, minus 2. We have 1, 6, minus 7. Is that okay? So the question says we should find A, B, plus Q. Matrix B plus Q. B, matrix B minus Q minus D. Are you true?
Yes.
So D, help me add D. Capital N plus R. Matrix N plus R. E. E.
N minus R.
Yes, capital N plus R. Matrix N plus matrix R. E. 2P plus Q. 2P plus Q. 2P plus Q. F. F. R minus N. R minus N. Finally, G. G finally. R plus P. Let me quickly explain that one. R plus what? P. Abi? If you look at matrix R, it has 3 by 3 matrix. Matrix P has 2 by 2. There's no way we can add it together. Is it clear?
Yes.
So that one, the answer for that one is impossible. So that's how to handle it.
So it doesn't really look so
To
hard.
answer the question, A? No, it's not hard. It's not hard. It's not. This one is so direct. Matrix is just multiplication and addition. Finding determinants is not something. So matrix P plus Q. Remember, matrix P is a 2 by 2 matrix plus another 2 by 2 matrix. There's no way I can add 2 by 2 to 3 by 3. No. The matrix addition in most cases should be that the number of matrices must be equal to the other one for us to add. That means 2 by 2 can be added to 2 by 2. 3 by 3 to 3 by 3. In a simple language, maybe 3 by 2 can be added to 3 by 2. Are you following? So the matrices must be the same. If it's 2 by 2, we add it to 2 by 2. 3 by 3, we add it to 3 by 2. If it is 3 by 2, we can also add it to 3 by 2. But they must be of equal rows and column for you to carry out addition. The first one, 5 of matrix P plus 8 plus 8 of matrix Q, comma, minus 2 plus 4. That's the first part. Second part, 1 plus 6. Then we'll have plus 8. Our final answer is 13. 2, 2, then 7, then 12. Final answer. Is it clear? 13, 2, 7, 12. Are you still there? Are you still there? Are you there?
Yes, I'm here.
So the answer is 13, 2, 7, are we? So you can add the rest, Abby.
Yes.
Okay. PQ, you can do that. QP, you can also solve that. So the next thing is, let's see how we can do multiplication. Then we'll call it a day, Abby.
Yes.
I will consider it. The thing is tiring. It's a lengthy one, unlike that one. Okay, let's just see how to multiply. We'll come back with next time with determinants and how to sum. So with this now, is how to multiply. With that same multiply, with that same question. In the price of result is still R times what? C, which is roll times what? Column. Roll times column. In this case, we'll have a PQ, P times Q. I'll call this one question A for multiplication of matrices. P times Q is not the same thing as Q times P. Take note in multiplication of matrices. So, according to the question, we had 5 minus 2, 1, 4 for matrix P. A matrix Q, we have 8, 4, 6, 4. Now, the first rule in matrix P is 5 minus 2 multiply by the first column of matrix Q. The same rule, multiply the second column, which is 4, 8. Did you get that? It will now be 5 times 8 plus minus 2 times 6. That will now give us 40 minus 12. I will now have 28. This one will now be 5 times 4 plus minus 2 times 8. This will be 20 minus 16. Result to be 24. Are you there?
Yes.
Okay. So did you understand that the first rule of matrix P will multiply the second rule, first and second rule of matrix Q? We'll repeat the same thing. Second rule of matrix Q, which is 1, or we'll multiply, that's in 8, 6, 1, 4. We'll also multiply 4, 8. And for more indication, 1 times 8 is 8 plus 24 to give us 32. This one will be 1 times 4 plus 32. Answer is 36. And that means our final answer will be 28 and 4 as the first rule. 28 and 4 as the first rule. 32 and 36 as the second rule. So in a simple language, PQ will be equal to 28 and 4 and 32 and 36. Did you understand?
Yes.
Okay. We leave it like that. So what you are going to do for me, you have to multiply for me at home. Q what? P. Remember I told you that PQ and QP are not what? Equal. When I multiply PQ, I got 28 for 38, 32, 36. Then you also try and multiply QP. We need that multiplication, it's important to do it. Then you also try out NR, and that is all. So when you try out that multiplication, remember that as you are multiplying, you are equally adding. And with that, we can say that's all we can take for today. Any other question?
No question.
No question. Okay. So that means we'll finish this what is it called? This matrices, and then attempt trying to look at the QE model, at least in 2 classes or 1, a stretch one like this, we can finish all. Which you are the best. It should be
Yes.
So we'll meet again. We'll meet again tomorrow next, Abby.
Yes.
Okay. Bye for now.
All right. Okay. Bye. Thank you, Mr. Vincent.